And here we are for part 2 of Rules of Divisibility. Welcome back, my gems in the raw. Let us share and continue. So last chapter, we ended with numbers that will divide by 10, 5 and 10. So far, we've done numbers that will divide by 2 or 3 or 9 or 5 or 10. Again, you may come back at any time. Today, I will continue with the poem and the relevant explanations. We go to a big one, dividing by 6. Multiples of 6 pose some defiance, a bit stubborn. Combine 2 rules to make 6s compliant. Got to do 2 rules. Take the rule for 2 and the rule for 3. Learn these well, so students will see that multiples of 6 are even 2. And the sum of their digits prove to be true. When trying to divide any number by 6, rules for 2 and 3 must be in the mix. Here's what we're not so aware of: that all multiples of 6 are even. Start with that. All multiples of 6 are even. But they're also divisible by 3. So we have to take the rule for 2, look for the even number first, then add the digits to see if it will work for 3. And I'm going to tell you, when we have a large number, anything bigger than 200, we might be wondering, we're sitting there picking at the numbers and wondering, well, what can I divide? Add the digits. First, is it even? If you get a yes, add the digits. If it divides by 3, you've got it. It must divide by both 2 and 3. And so that's my explanation in the box in green. So I've got some examples. Can 123 divide by 6? I can say no right away because it's not an even number. Throw it out. Can 432 and 582 divide by 6? Maybe, because they passed the first test, they can divide by 2. So let's add the digits. 4 and 3, 7 and 2, 9. Oops, that works. 8 and 5, 13 and 2, 15. That works. So they're both divisible by 6. It takes getting used to, but it'll help as long as you remember that the rule for 2 and 3 will both work together with a number that is a multiple of 6. Get a friend, try numbers out. Have one friend come up with a 7-digit number. Anyone, any 7-digit number. Then check, is it even? If not, throw it out. Have another friend come up with a 7-digit number. This time, make it an even number. You still have to check to see if it's divisible by 3. So add the digits. If it is divisible by 3, if the sum of the digits is divisible by 3, then that number is divisible by 3. Okay. Maybe a challenge, but it's worth it. It really is. Now let's go to 4. That's our last one. Knowing the table of 4s is essential. For dividing by 4, it is preferential that 4, 8, 12, and 16 are the endings of examples supreme. 1104 and 2112 all have the endings that help us delve into the mystery of the 4s, so unusual to see, the absolute fascination of number theory. So we must know the 4 times tables. And I put the endings of sum. 1 by 4 is 4. I've put 2 digits. So even if our number is ending 04, that'll work. 04, 08, 12, 16, 20, 24, 28, 32, 48, 60. You know, any number that is a multiple of 4. So check out your 4 times tables and take the last 2 endings. Now, I've put some numbers that we can practice on. 244. Will it divide by 4? Well, the last 2 digits is a multiple of 4. That's going to work really, really, really. Take a calculator, divide by 4, see what happens. So I'm going to use my calculator, just so I'm fast. Divide by 4. I get the answer 61. That works. 1048, 1048, divide by 4. What do we get? 262. No remainders. Told you. Next one. 32924. The last 2 digits, 24. 24 is a multiple of 4. The whole number will divide by 4. 4 is pretty fascinating, and it's very simple as well. So if I punch in 32924, divide by 4, what do I get? 8,231. It works every time. Try it and see. And welcome, and thank you, and come back again anytime. Bye.